Hello, my name is Vladimir Grachev. I represent Natomas Engineering from Sacramento, where one can obtain the software we'll discuss, and the city's company from Ekaterinburg, Russia, the developer of the models. The main idea to develop macroscopic evacuation model is the ability for BIM and fire safety engineering integration. So the ability to be more easily converted from BIM model inside the BIM authoring software and to produce a relatively small amount of data that need to be stored back in the BIM model for future analysis. The model is based on the principles and data mainly from the book of Predtechensky, Planning for Foot Traffic Flow in Buildings. We use the second edition of this book, and also we use ideas from SVP handbook about boundary layers of flows and results of studies of Russian researchers Kopylov and Samoshin, the ideas about the flows with high density. The main properties of flows in the model are the first, flow speed is the function from density and the type of compartment, for example, corridor, door, stair, and so on, and the width and slope of stair or ramp. There are three main properties. The maximum width of flow in white space, angle of extension of flow after the door opening, and the angle of narrowing of flow before the door or opening. Also, the flow speed function at areas near the flow concentration, for example doors, must take into account several effects: arch effect, false opening effect, and similar effects of turbulent pedestrian flow. And flows can have boundary layers. To produce calculation, first we need to make a discretization of space and time. Parameter of time discretization is calculations time step. It is constant for all simulation. And the parameter of space discretization is length of flow path field. There are three types of flow path fields in the model. The first is the fields where flows where pedestrians are freely moving to nearest exit from the room, the flow formation fields. It's marked yellow on the slide. The second are flow fields where the flows goes directly. They are marked green. And the third is the areas where flows are merging. They are marked blue. To make calculation, we use evacuation scenarios as a combination of different options. Options are the tenant distribution, available exit option, door state option, obstruction option, and the used option for speed density function. The scenarios like a combination of options facilitate make event trees for future fire risk assessment. The software application kit has two main parts. First is the add-in for BIM authoring software. We start with Autodesk Revit software, but the same ideas can be put in any other authoring software. They didn't work with project database, work with solid BIM objects, such as floors, walls, ceilings, doors, openings and others, and produce the simplified objects with boundary representation that are suitable for future fire safety engineering calculations. These objects has faces like floors, walls, ceilings, etc., with simply openings near the doors and the walls. The data for fire safety engineering simulation are stored in the text comments for objects, BIM objects or simplified fire safety engineering objects. This data is in a text form and can be edited via regular interface of authoring software. To facilitate editing this text data, there is an option to make a mapping from the names, for example, names of the rooms, to the fire safety engineering data in the text comment. For example, if the name of the room has the word office, you can map this word to the density, occupant density per person per square meter in this room, fire load and other data. After the creation of the simplified model, the data are passed to modeling processes, and after simulation, the data are inputted back inside the DIN and are stored in the project database and are available for future analysis, making drawings and other tasks. Also, it is possible to make text reports that can be presented as a text document or HTML website. There are some images. The top left is the BIM model. It's the test case model for evacuation, so there are no windows. At top right is the simplified model, and you can see the small red cube at the corner of the model. It is the model object, the object where one can place data for simulations, for example, data about scenarios and some fire data and others. At the bottom there are images of data, the results of the simulation that can be seen like spatial fields or vector fields. For model verification, we have made a set of BIM models that we can find in different sources. For example, Maritime Organization Guide, RIMEA Guide, International Standards, Verification Guide of FDS Evac software, and the NIST report about World Trade Center evacuation. There are some images of these models. To make verification, we have used three options of speed density functions. Three of them are from Predtechensky book, the comfort movement, normal movement, and extremal movement that is similar to the German guide for fire safety engineering. Also, we have used the functions from a fire risk assessment guide that is used in Russia, and the functions from SVP guide from United States. There are difference of these functions. The difference of these functions are shown on the slide. The first example that I will present is the test case 633 from FDS Evac guide. This case is, the case is a room with 1,000 persons and a corridor with 2 turns. As you see on the plot, the difference between the calculation results in macroscopic model with different speed density functions may be in accordance with the difference of different agent-based evacuation software with different options. So the idea is that the model can be calibrated to the task, but by using the proper speed density function. And the second verification example is the observed evacuation during the World Trade Center 1 evacuation after the attack at 11 September from NIST report. This model is a 107-story building. The people is located in the model from the 3rd to 93 floor, about more than 7,500 persons. And on the plot you can see the results of observed evacuation data and results of simulation. The best fit is of the results to observed data is the use of the function from German guidance and functions from Predtechensky book. The Russian guidance is more quick than observed data, and SVP guidance is slower. Conclusions. Software tools are developed and now available for beta testing. The Revit add-in for fire safety engineering modeling and several processors and reporters. Also, macroscopic evacuation model is also developed and is now available for beta testing and verification. Thank you.
Thank you.
Questions?
Yeah, do we have any questions here?
More or less a comment. Thank you very much, Vladimir, for your really good presentation. As a German, I'm really, really glad that you showed Predtechensky and Milinsky, because this is something we are using historically in the German-speaking countries still as a hand calculation. And quite often we have to show that our simulation results with, that we gained with Pathfinder simulation is somehow close to a hand calculation, because our authorities or the fire inspectors, they do not simulate, but they know how to do the hand calculations with Predtechensky and Milinsky, because this is something that we have learned as engineers for I don't know how many years. And I try to convince our Pathfinder team to implement this into Pathfinder, not only to have the SFPE method inside as an hand calculation tool on top of it. So I'm very glad that you showed how good our German guide is compared to the other to the other possibilities that there's worldwide used. And another thing that I'm really glad to be seen in your presentation is that you can match it somehow to BIM, because this is something what we are discussing in Germany, if with our BIM models, the hand calculation somehow are out of use. So this is really good, really nice talk. Thank you very much.
Thank you.
Any other questions, thoughts? One question I had is, where would somebody go to follow up for beta testing or to look at the tools? Do they visit your website or contact you directly? What's the best way to
there is a website, Natomas.com. There is the software for Revit add-ins. There are software Revit add-in with the combo add-in with processes inside. There is a lack of documentation in English now, but I think some things are intuitive. And there are models that I have mentioned that anybody can take model and try to make some calculations and reports. And the documentation, we are working on documentation in English, and I think that it will appear soon.
Okay, great. Thank you. Anything else? No? All right. Thanks so much.